Alright, I'm going to look at factoring a polynomial, and I'm going to use the chart method. So the first thing that you want to do is you want to create a chart that has space for each monomial in your polynomial and then one extra row. So I have 3 monomials here, so I have 4 boxes here. You're going to list in the first 3 boxes here each monomial separately vertically. If it has a negative sign or subtraction with it, make sure that you have a negative with it. So the first one is negative 6x squared y. The second one is a subtraction, but we're going to put a negative with it. So we have negative 12xy squared, and then a positive 3xy. We list each monomial in its own box separately. Then in the next box over, we need plenty of room because we're going to write this out in an expanded form with all of its factors listed out. So we want the prime factorization of everything. If it's a negative, the first thing that you want to do is write a negative 1. Then we're going to look at 6. The prime factors of 6 are 2 and 3, and then you're just going to list each of the variables. If it has an exponent, you list that variable that many times. If it doesn't have an exponent, like this one doesn't have a explicit exponent, you just write it the one time. So we need 2 x's here and a y. The idea is that if you multiply each of these terms together, it gives you this monomial. So for the next one, it's negative, so I put a negative 1. Then I want the prime factorization of 12. So that is 3 times 2 times 2. I have a single x, and I have exponent of 2 on my y, so I write 2 y's. The last one, I have a prime, so the only factors of a prime are 1 in itself, and then I have an x, and I have a y. Alright, the next step is to go through and circle the terms that are in common in each line. For instance, I have a 3, a 3, and a 3 on each of the 3 lines, so I want to circle that. Next, I have an x, and an x, and I also have a y, and a y. I don't have anything else in common. I have a x here, but no other x's here. I have a y here, no other extra y's anywhere else. I have a 2 here and a 2 here, but no 2 here, so it doesn't get circled either. So the things that I have circled in common, I'm going to write down here. So I have a 3, an x, and a y. That was circled on each one. When I multiply those together, I get 3xy. Over here to the side, I'm going to write everything that wasn't circled as a product. So I'm going to multiply negative 1 times 2 times x to give me negative 2x. Negative 1 times 2 times 4 is negative 4. And then 1, there's nothing else. 1 times, it's just 1. Here we don't have to write anything in this one. So now what I'm going to do is I'm going to use this and these to create my factorization. I'm going to write the first term here, this monomial 3xy that we found, and then I'm going to open parentheses and write each of these terms down in order. I missed something. There was a y here. There we go. The reason I knew I missed something here is because these would have added together, and that would have given me a different polynomial. So I had a negative 1, 2, 2, and a y that I didn't circle, so I have negative 4y here and negative 4y here. This is my factorization. There's nothing else in common that'll come out of here. This is in common, and I took it out of there. If I would do distributive property here, I will get back to my original problem. So you use distributive property to get back to the original so you can check yourself. This chart method is basically allowing us to do the reverse of distributive property. It pulls out a common term out in front and leaves you a polynomial that has no common terms. So the final answer that we want, that we would have to give, is this.